Okay, good evening, everyone. My name is Fred, and I'm happy to be here with you tonight. I realize that I'm the only thing standing between you and beers at the cocktail after, so I will try to make it as concise and sharp as possible. Tonight, we're going to talk about production design. We're going to talk going from the demo MCP server to the production-ready MCP server. And I've seen a lot of hands raised during the question from Geoffrey about who is building MCP server down here tonight. So I hope you will have some takeaways from this presentation about how to make it more efficient. I'd like to start this talk with a simple question. What makes an MCP server successful? What makes it efficient at what it does? And in order to answer this question, I like to make parallel with existing ecosystem in the web as we know it. For example, when you build a mobile application or a web application made for users, you will usually try to maximize user experience with talented UX designers that are looking at the Net Promoter Score to make sure that those web application and mobile application are behaving as intended and solving users' problems. The same way that you do for users when you build REST API to be integrated in third-party softwares, you are relying on experienced software architects that will try to maximize developer experience and measure it using the latency on their API or the integration time that took another team to build on their existing API. When you start to build MCP servers that are here to provide your business services and products to a new type of users, those AI agents, what you want to look for is to maximize the agentic experience with a new person in town, the agentic experience designers, that we try to maximize the North Star metric, which is task completion rate. Task completion rate is the ability for an agent to perform the task successfully with just the initial user input. And we will try during this presentation to maximize this task completion rate. Problem that we have with the task completion rate that is a proxy for the agentic experience is it's hard to measure in production. And it's hard to measure in production for two reasons. First one is, as an MCP server developer, you only get part of the full flow. You only get visibility on part of the full flow. So you don't have access directly to the conversation that is happening between user and the model behind the client application. You only get requests that come to your server once the model has decided that it's good time to call your tool with those parameters. The second problem that you face when you develop MCP server to measure the agentic experience is there is a wide variety of clients out there with their corresponding models, and they do tend to perform varyingly. So on the left here, you get an extract from the BFCL, the Berkeley Function Calling Leaderboard, which is a leaderboard of all models, a ranking based on their effectiveness to do a successful calling. And this range from 16% success rate to 76% success rate. So out there, when somebody connects to your MCP server, you have no guarantee that it's going to be using the most performant model out there. If you use a client, you also have variety in the quantity of features from MCPs that are supported by the client. So measuring one time the agentic experience, the capacity for a single configuration to perform well for a task at hand is tricky because there are so many different environments out there. So in order to measure the agentic experience, we'll rely on proxy metrics. Two of them are measured during the software development lifecycle, and two of them are actually measured in production. The one that can be measured in software development lifecycle is what we call tool accuracy and parameter accuracy. So it's giving a certain scenario, the ability for the model to call the right tool with the right set of parameters. And this you need to benchmark in a controlled environment, and that's why you have to measure it during the software development lifecycle. two other of those proxy metrics can be measured in production, and they do have an impact on the tool, on the task completion rate. First one is cost, but we measure it in terms of token consumed within the model context window. So the more token you output from your MCP server that will end up in the context window of the model, the more chances you have to have a stochastic system going in the wrong direction because it forgot what was there at the beginning of the context window. So big concise of the use of the context window, and in order to do so, try to minimize the cost, so minimize the quantity of tokens that you send. Latency, and here we are not measuring latency in seconds, we are measuring latency in terms of quantity of back and forth between the model and the MCP server. The less you have, the better it is for the task completion rate, because same thing, you have less chance of diverging from the ideal path if you don't have 10 steps going back and forth between the model and your MCP server. What we'll do during the rest of this presentation is see some actual design patterns that you can implement and see their effect on those 4 proxy metrics of the agentic experience. The results that I will share with you today are made using a specific benchmark. I'm using OpenAI Agents SDK as an MCP client. I'm using GPT 4.1, the one back from April, as a model. Everything is in English. The MCP servers ecosystem that are connected to the model are the one from the B2B SaaS industry. So there are stuff like GitHub, Linear, Exa, Slack, and Notions that are throughout the mix. And every measurement that you see has been iterated over about 100 times to get a statistically meaningful result. Bear in mind that those numbers are absolute numbers, that they may vary a lot from the actual benchmark that you run with various parameters changed. What is important here is to focus on the evolution of the metrics that I would share rather than the absolute numbers. There are 3 locations when you're developing an MCP server that you have an access on. There are 3 surface areas that you can change in order to have a positive impact on the agentic experience of your server. First one is at the beginning of the session during the tool list when your MCP server advertise the available tools that the model can use. During tool use, when you answer with the result payload, and when the MCP server emits tool list change notification. Let's take a look at the first one. And there are 2 things that we can play upon. First one is the quantity of tools available. Here you can see on this presentation the evolution of the tool accuracy, so the capacity to select the right tool for the job to do, based on the quantity of tools available through the MCP server for the model to be using. You can see that it drops really, really fast. So the more tool you use, the less chances you have to have the model actually call the right tool. And it decreases logarithmically. The quantity of tokens that you use in your context window is linear to the quantity of tools that you use, and the quantity of iteration has no impact during this test. What you see is really this tool use accuracy that is dropping very fast. And that's why you have clients like, for example, Cursor, that are limiting the quantity of total tools that you can connect at one point to make sure that the experience doesn't go above 50%, below 50% tool use accuracy. However, we see a lot of MCP servers developed out there that are basically wrappers for API, for existing APIs. And the main concern with this kind of design of MCP server is that you usually get very fast to a large number of tools exposed through the server. And as you've seen just before, this is very detrimental to the overall agentic experience that you provide, because you have very few chances to actually have the right tool being called. So you could go the other way around and say, okay, we are not going to change the quantity of tools available to the server. We'll rather increase the quantity of parameter to allow for more polymorphic tools. So slightly similar features will be grouped together in one tool with additional parameters to say if we want to go the way A, B, or C, for example. And running the same test, you see that this is slightly better. So increasing the quantity of tool parameter only decrease linearly the tool parameter selection accuracy, which is better. The token quantity is as well impacted linearly, and there is no more iteration doing more parameter. One very extreme example of this pattern is the layer tool pattern that was initially proposed by Block, the company behind Goose, which states that you can describe any domain-specific, any domain with an MCP server using only 3 tools. One to discover a big area of concerns, service, like catalog, payments, HR. One to discover available methods in a specific service with the corresponding tool parameters, and one to actually make the call. With this kind of pattern, you could envision the full API of AWS, which are more than 3,000 endpoints, being compacted together in one single MCP server, which only has 3 tools. But going this way has a trade-off. Every time you need to call one tool, you need to make 3 movements back and forth between the model and the MCP server. One to discover again the service, one to discover the methods, and one to actually make the tool call. So it's always a responsibility of striking a balance between making a one-on-one wrapper and making a layered tool pattern where you only have 3 tools. And the best way to visualize it is to think of tool design pattern as packaging agentic features. So you want one single feature to be behind each of your MCP tool available on your server. For example, here you have the GitHub tool, which is called push files, which package 3 of their API, basically creating a new branch, adding files to this branch in a single commit, and pushing the branch on the remote. All those 3 actions are combined together in a single tool, which is actually a useful piece of technology for a developer trying to push a new branch on a remote. Another last thing that we've seen having a lot of positive impact on the agentic experience is in the design of your parameters themselves within the tools. Stay close as much as possible to what the user is probably going to input during the conversation. So if you're expecting a date, stay close to something which resembles a human-readable date. Doesn't go for a timestamp because you ask the model to do the conversion and you have less chances to actually get the right timestamp. If you're asking for an interest rate, even if the correct mathematical number is 0.03, it's better to represent it as a percentage, which is hopefully something that the user is going to input to ask for the remaining rate of his interest. That's all for tool listing. Let's take a look at tool use. So what you send as an MCP server in response to a tool being used. First of all, when the tool use is successful and you want to answer with payload of something that has been created or changed, try to, again, be respectful to the token window, to the context window of your model, and remove redundant information from your payload. Here, for example, you have a JSON payload from the Stripe API when you create a new plan. And you can see that for an LLM, you have a lot of redundant field, the amount being both stated as a string and as a number, which does not add to what the LLM will actually be able to see. You also have properties which are null, empty object, undefined, real stuff, so you don't need them, and it will actually be better for the usage of the context window of the model. When you have a non-successful tool use and you want to respond, there is something very useful you need to leverage, which is that you are certain of the model using your error message to try and do something to fix it. Unlike a user, which can discard the error message and not come back to your site, unlike an API, which might not be correctly implemented by the developer consuming it and not using the actual HTTP code to do something useful, you have 100% guarantee that the errors that you will be returning from your MCP server will be consumed by the model. So if you have an input validation error, be very precise about what is the error. If the date is in the past, because, for example, the model still thinks it's 2024, and you need something in the future, you can actually answer by saying the current date, so that the model has a chance to try again and call you again with the correct date. If you have no idea what the error is, try to provide some helpful message for the user to be able to do something. Do not at any cost just say that an error occurred. This is wasteful of what the LLM could actually do behind your tool use. Last surface area where, as an MCP server developer, you can have an impact is using the tool list change notification. In summary, don't. All models out there are building some kind of cache to be faster on the answer. Usually, the key generation for this cache is based upon system prompt and tools. So if you change the quantity of tools or the definition of them, you have high chances of invalidating cache for the model that is behind the application you're using, thus ensuring that the response will be slower. In summary, when you develop MCP server, always try to favor more parameters in your tool rather than more tools. Try to think in terms of agent stories that are full piece of features that are delivered to the agent. Strip useless attributes from your successful return. Always return meaningful error message to let the LLM try again. And do not change the tool list mid-session. In addition to those good tips, try also using the full spectrum of the MCP protocol. Resources and prompts are ways to give back some control to the user and avoid always being faced with the stochastic result of an LLM. Elicitation is another way, much more recently introduced in the MCP protocol, to solicit user input for additional information to be able to complete the task successfully. Try to implement it as much as possible. A few of the tools that I've been using in order to share those results with you today is listed here. You can feel free to grab some. I'm going to talk a bit about the one that we developed at Alpic, which is called MCP Eval. It's an open source tool that you can use to describe during your software development lifecycle meaningful scenarios for MCP server in order to test them during your CI/CD phase and ensure that you don't impact negatively the efficiency of your MCP server. You can run those tests using OpenRouter on any of the 3 assistants that we support at the moment, which is Lusha from Mistral, Claude from Anthropic, and ChatGPT from OpenAI. Those simulate environment that you have in those clients, basically emulating the system prompts that they have and the available tools that are existing in those ecosystems that you often try to battle against when you give your own tools available to a model. We do as well have a platform at Alpic, which can help you for the deployed servers that we're hosting, measure in production the 2 other proxy metric of the agentic experience, which is basically the average quantity of token output by your server and the quantity of interaction in a session. We also do other things like auth scaling, monitoring, evaluation, in addition of those 2, and the deployment, sorry. If you want to know more, feel free to scan any of those 3 QR codes. First one will take you to the platform. Second one will take you to my LinkedIn. And third one will take you to this presentation if you want to see it again in the future. And with that being said, happy beers.